So transformations is like the umbrella, and then I will teach you several different transformations by name. But first I want you to just understand the idea of a transformation. So with a transformation, you can have a change in position. So where something is sitting, a change in position, a change in shape, or a change in the size of the figure. Okay, so if I say something undergoes a transformation, one of those things is happening. For the most part, what we're going to deal with is a change in position. We'll do a little bit of change in size as well, but most of what we do is just a change in where it was. So if it was here and it slid to a new spot, still the same size, still the same shape, it just moved to a new place, that type of thing. So I'm going to give you kind of the three basic transformations that we're going to see. This is just like the layman's term for them, and then I'll give you more specific terms as we go through each one. But this first one, pretend those look like they're the same size, because I know my drawing skills are not A+. But that's a flip, right? It started here, it flipped over and became a different figure. That's one of them. Another one that can happen is a turn. So it was here, and then it rotated or turned, and now it's here. Hopefully you're a better drawer than I am. So a flip, a turn, and then the one that we're going to talk about today, I would say is the easiest of them, but maybe you'll disagree with me. That one is a slide. So it was here, and it just slid to a new place. That's a slide. Excuse me. Okay, so a flip, a turn, and a slide are the things that we're going to talk about. With these, there's always two figures, okay? There is the pre-image and the image. The pre-image being the one you started with. Okay, so the pre-image is your original figure. Did it just wig out again? No. And then the image is whatever it becomes. So your resulting figure. Okay. So you're always going to have those two, pre-image and image. And it is really important to make sure you know which one is which, because I'll ask questions, and if you give me the pre-image instead of the image, it doesn't work, okay? So make sure you know think pre is before, right? So pre-image is the starting image. The image is what it became, okay? Your final result. With these transformations that we're going to have, some of them will be what is called a rigid motion. Okay, and a rigid motion, we say it preserves distance and it preserves angle measure. So we'll just say this preserves distance and angle measure. Okay, and let me just give you a for instance so you know what I'm talking about here. If I were to give you this triangle, okay, and then it became this triangle. Oh dear. Okay. When we say it preserves distance, we're saying the distance between points is the same. So basically we're saying it has congruent sides. So this stayed the same, that stayed the same, and this stayed the same. Okay. And it preserved angle measure. So all of our angles also match up. What does that mean about those two figures? If all the angles and all the sides are congruent? the figures are congruent, right? So a rigid motion is only when you have congruent figures, okay? In other words, what would not be a rigid motion is if I had this triangle to start and it became this triangle, right? So it slid to a new place, but it got bigger. That is not a rigid motion, okay? This is considered a rigid motion. So if it stays congruent to what it started as, it is a rigid motion. Yes? That's okay too. Like if you had something like this and then it became this, as long as they were the same size, it's still considered a rigid motion. So it's really about preserving angle measures and the distance between points. Okay. So first example. Let's say, the question is this: is it a rigid motion? And you might hear at times, they'll talk about an isometry. That's the same thing as a rigid motion. So if you see isometry, think rigid motion, okay? Is it a rigid motion? So let's say I give you this figure and, oh dear. Pretending that I know how to draw well, and those actually are the same size, is that a rigid motion? Yes, I would say it just flipped over maybe, because I feel like this angle and this angle were supposed to match up, but I didn't do a very good job of it. But it just flipped, okay? They are the same size, the angles are the same, the side lengths are the same, so that is an isometry or a rigid motion. So is that a rigid motion? No, right? If it changes size, not a rigid motion. Okay? Go ahead and turn that off. Okay, some of the other terminology that you're going to see in this comes from an arrow. When you see an arrow pointing from like one triangle to another triangle, from one set of letters to another set of letters, whenever you see that, we say maps onto. So becomes is another way you could say it, like this figure becomes that figure. It maps onto another figure. So just pay attention when you see arrows. You'll see lots of them in this chapter. That's what it means. Another thing, when you see the little, let's see here. We'll just do this. When you see this little like apostrophe, okay, this right here, that is prime. So when you see A with the little apostrophe, we would say A prime. So how you're going to see it a lot of time is they're going to say A from one figure maps onto A prime in the new figure, okay? So this is kind of the setup that you'll see a lot, is something maps onto something very similar to it, right? A became A prime. So A was the pre-image, A prime was the image. Eric, take your earbuds out. Not like that, like out. So you're not tempted to put them back in again. Just take your hood off. There we go. Okay, so what you're going to say for like a figure. This, for instance. If this is J, K, and L, and then we have this figure. J prime, K prime, L prime. Okay, I would say right now that triangle JKL maps onto, remember that's what you're saying here, maps onto, and then it's triangle J prime, K prime, L prime. So it's like, here's what the triangle started as, here's what it became. Okay? So just like we did with congruent figures, you have to match up the corresponding parts, and then you're good. All right, so how would you say, if I told you this, let's see, example 2. If I told you that triangle ABC maps onto triangle A prime, B prime, C prime, and these were our triangles. Technically, again, you don't need the picture on these, right? We know what corresponds just by the order that's given, but they will often give you a picture too. But let's just say we had this setup. So here's A prime, here's B prime, here's C prime. Because I told you triangle ABC maps onto triangle A prime, B prime, C prime, you should be able to tell me corresponding angles and corresponding sides, okay? So what if I said, what is the image of angle A? Okay, so the image of angle A. That means the pre-image is A. What is its image? What would that be? That's A prime, right? You're just saying the one that's related to it. The image of A is A prime, okay? What would be the image of angle C? C prime, okay? So then same thing can be true of the segments. If I said, what is the image of segment AB? We would say AB mapped onto what?
Segment AB.
Right, segment A prime, B prime. Okay, so hopefully at this point it doesn't feel like a whole lot of new. It's just that it looks a little different, but it's the same ideas that we used before. It's just that we're writing the primes and the arrows for mapping and that type of thing. Yes, ma'am.
You know, it's like A purple, like C purple, whatever, like it's a letter form.
Mm-hmm.
Is it possible that like 2 letters in the front, like A, C prime?
I think they typically write it like this with the prime behind each one. You mean you're trying to name a segment and you just call it AB prime? I think they typically do it with the prime on both. I feel like I would probably be okay with you doing it like this because I know what you're talking about then. Actually, no, you should put it on both because sometimes there's an A that like overlaps the two figures. So sometimes it's A is A prime essentially, but it's only listed as A in the problem. So I would just, whatever you see in the picture, put the prime behind where you see it. If the A has the prime behind it, put the prime behind it. Yeah, good question. Okay, so here's the deal. That's 9.1a. Just kind of the, like, here's what you need to know for Chapter 9, how you label things. 9.1b is the first transformation. I was going to just teach 9.1b right away because I feel like 9.1a isn't really a lot of practical do-it stuff. It's more the details that go along with what you're going to do in 9.1b. Are you okay with that?
Yep.
Okay, here we go. So this is 9.1b. So the first transformation we're going to talk about are translations. Okay. The other word for a translation is a slide. So if you're thinking in picture form, I feel like slide makes a lot more sense to people, but just know that a slide and a translation are the same thing. Okay, so a translation there we go. Also known as a slide. Will map all of your points onto your new figure in the same amount of distance. So if you want a definition, you are welcome to write a definition down. I feel like it just makes more sense to draw pictures. So I'm going to draw a picture of this for you. And then if you are uncertain of something, let me know. So let's say this is triangle ABC. And then we have triangle A prime, B prime, C prime. Okay? A translation means this. It means all of your sides are the same still. Okay? It means all of your angles are the same still. So angle A and angle A prime, B corresponds to B prime, and then C corresponds to C prime. Okay, so we have a rigid motion here, right? They're the same size figure. But then the translation part of it is that it moved the same distance to get from one to the other. So for instance, if I were to draw a connection between B and B prime, that distance, that dotted line distance, should be the same as A to A prime and C to C prime. So all of these should be congruent. So this segment is congruent to this segment, is congruent to that segment. Okay, that's a translation. It just slid to a new spot. You are going to be doing some graphing in this one, and really this whole chapter. There's different things that you'll graph about this section, and there's other things that you won't have to graph. You'll just look at it and kind of talk about what's changing with it. So if you don't have graph paper, by the way, I have tons of graph. All right, so on grid paper, on graph paper, what you're going to be seeing is something like this. And let me know if the colors I choose are not showing up dark enough. I really should get a better piece of graph paper here. Okay, so let's say you have this triangle. You have point C at 0, 1. You have point B at -2, 1. And you have point A 3 units above that. Ooh. Okay, so we have that triangle. And then we have the second triangle. We'll see if this color shows up for you. That's what? That's terrible, huh?
Only low key though.
Better? Okay. So there's A prime. B prime is here, and then C prime. So your new triangle looks like that. This would be a translation, okay? And the way that we would write it, if you think about your x values, for instance, B was the point, let's see, -2, 1. Okay, well, B prime became the point 3, -2. Okay, you got to think, how much did those move? So your x-axis changed from -2 to +3. How many units is that? 5, right? We were at -2. We moved to +3. So we went 5 units. So it was our x value plus 5. And then our y value went from a 1 to a -2. How many units was that? -3, right? We went down 3 units. So it's our y value minus 3. So that's kind of the transformation that's happening. The way you will write it is this: a transformation of +5, -3 of triangle ABC became triangle A prime, B prime, C prime. Okay? This is telling you what's happening. And it's, you do like pointy brackets and you do it subscript. So you drop it down lower and make it the pointy brackets. Okay? Yeah, say here.
How do you do the pointy bracket at the top of the x plus 5?
This was just me comparing, like, so we were at -2 and we moved to 3, so my x value just added 5. And then this one we were at 1 and it became -2, so my y value went down by 3. So this was just, you're not going to have to do this part of it. It's just me showing you how it works. Yeah, Rachel.
Is it like different, well, I know it's different each time though. Like for the point about x plus 5 minus whatever.
Yeah, this will change every problem, but it stays the same for every set of points in one problem, right? So it's up to you which point you start from. Like if I start at A, I would go 1, 2, 3, 4, 5 to the right, and 1, 2, 3 down. That's 5, -3, right? If I start at B, it's 1, 2, 3, 4, 5 to the right, and 1, 2, 3 down. So still 5, -3. Okay? This is actually how I prefer to solve it. I don't usually use the numbers and do it that way, but you can do it either way. Okay? Okay, so here's the deal. Let's say for this first example, which is actually our example 3, that we have this question. What are the vertices of, and here's where they're naming it for you, T -3, 4 of triangle ABC. Okay, so this is saying a translation, that's what the T stands for, which right now that's all you know is a translation, but you will get a rotation and a reflection and a glide reflection. So you just need to make sure that you're associating each letter with the right thing. So a translation of -3, 4 of triangle ABC, and I'm going to give you your triangle ABC. So go ahead on your graph paper. You can plot this triangle. So if my ABC is 3, 3 is your A, 5, 1 is your B, and then 1, 0 is your C. Okay, so let's say we start with this triangle. Man, that's real bad. Okay. The translation is -3, 4. So keeping in mind that this is your X value and the 4 is your Y value, what is that telling you to do? Where do you move? 3 where?
Across.
That's your left, right? 3 to the left because it's a -3 on your X. So from C, I am moving 1, 2, 3 units to the left, and then 4 where? 4 up. It's a positive 4, so you're going to go up with it. So 1, 2, 3, 4 would put us right here. What point is that? That is C prime. Okay? So that would be your C prime. A prime then, where am I moving from this A point? Left 3 and 4 up, right? 1, 2, 3. 1, 2, 3, 4 will give me my A prime. And then you do the same thing with B. Well, we should go left first so I don't mess you up. 1, 2, 3 to the left. 1, 2, 3, 4 up. Puts you here at B prime. So your new triangle, is this my pre-image or my image? The image, right? The image is what it becomes. So this solid triangle is your image. Your pre-image was triangle ABC. Your image is A prime, B prime, C prime. So when they ask what are the vertices and then they tell you to graph it, I'm fine with you just graphing it and showing me that you found the vertices. You don't have to tell me like A is, or A prime is 0, 7. B prime is, I don't need to necessarily see that. Okay? Questions on that? So you see it just slid to a new spot. They tell you exactly how much you need to slide it. -3, 4. Okay, now I'm going to give it to you the other way. I'm going to give you the graph, and you're going to give me the rule. So here's the rule right now, right? That T of -3, 4 of triangle ABC. You're going to give me a rule for this picture. Let's say we started all right, so if this is triangle LMN, is that color showing up for you? It doesn't look great for me. That's okay. And then we have M prime L prime, so 0 or -1, 0 is your L prime. And then your N prime is 1, -3. Okay, so here's the deal. And the thing that I see done wrong the most on these is not usually people getting the wrong numbers. Well, yes, the wrong numbers, but the opposite numbers. So instead of going from the pre-image to the image, they go from the image to the pre-image. So just make sure you're always starting at the one that doesn't have the primes and you're moving to the one with the primes, okay? So if I want to go from L to L prime or M to M prime or N to N prime, it should be the same rule all the way through. Excuse me, you too. 4 to the right, 2 down. Yeah. So if I'm going here, right, it's 1, 2, 3, 4, 1, 2. This one is 1, 2, 3, 4, 1, 2. So always 4 to the right, 2 down. So to write the rule, you're going to do what letter? A T, because it's a translation. It's a slide. And then you do your pointy brackets. What numbers are going to go in there? 4, -2. So this is a 4. This is a -2. And then we would say it's a translation of triangle LMN, which became triangle L prime, M prime, N prime. Okay? Notice how if you go backwards, if I went from L to L prime, it'd be -4, +2 instead of +4, -2. So just make sure you're going in the right order. Okay, last thing. Sometimes there's a composition of translation. So in other words, you went one place and then you went someplace else. Where did you end up? That type of thing. So I'm going to show you that in graph form right now. And then we're done. But this is more of a like real world type of setup. So example 5 here. And I'm not going to write it all out just because I don't feel like you need me to do that, but I'll give you the details. It says Carmen leaves her apartment and travels 2 blocks east. So 2 blocks east and 5 blocks north to the library. Okay, then she goes 4 blocks west and 1 block south to the grocery store. Okay, she lives in New York, guys. She lives in New York. Nobody drives in New York. Where is Carmen? What?
That's the reason there's a lot of traffic.
Yes, there's. or the other way around. They don't because there's a lot of traffic. Anyway, so if this is what she's doing, I want to know at the end of this, where is Carmen? Do you guys know Carmen Sandiego?
Yes.
Where in the world is Carmen Sandiego? Yeah? Oh, that was my jam back in the day. Like I'm old? I'm double you. I'm more than double you guys. More than double.
You don't even look.
Well, thank you.
You look like you just graduated college.
I'm 36. I'm more than double. More than double. That's really nice that you say that, but. Okay. So here's the situation. The question is, where is she in relation to her apartment? So where is a good place to put her apartment right now, would you say?
In the middle.
0, 0. Start right in the middle, okay? So this is her apartment. Okay, now let's walk through it. It says she walked 2 blocks east and 5 blocks north to the library. So where is 2 blocks east going to put us? 2 to the right, okay? So 2 blocks east, 5 blocks north, 1, 2, 3, 4, 5, puts the library right here, okay? Then from the library, she went 4 blocks west, which would be 4 to the left, and 1 block south. So 1, 2, 3, 4, 1 block south would go down to the grocery store. Okay, the question is, where is she in relation to her apartment? So her apartment's here, she's here. She is how many blocks which direction, how many blocks which direction from her apartment?
You could, didn't you go
4 blocks south and 2 blocks east.
wherever she could?
But you would go the other way, right? So here's the thing. From her apartment, she is 2 blocks west and 4 blocks north right now, right? So in relation to her apartment, that means you are starting at her apartment. Where is she? She is 2 blocks west. Did I say east? So you would say 2 blocks west and 4 blocks north. Okay? Questions on that?